Okay, so what about doing significant tests for the difference of two proportions? So just like when we were doing the intervals, we also have to have our conditions for performing a significant test about a difference in proportions. Again, you're going to have to check, is it random? Or were both of the samples random or taken from two groups in a randomized experiment? Is the 10% condition met? And also the large counts. But remember, you have to do 4 different large counts tests for successes and failures. And they will all have to be at least 10 in them. Okay, you're going to also end up having to remember your formula where you have to find the test statistic, which is the statistic minus the parameter over the standard deviation of the statistic. And don't forget that changes then to a z because we're using a z test for it. I want to close, okay. And our statistic is going to be p hat sub 1 minus p hat sub 2 minus 0, because our parameter is usually going to be 0, over the standard deviation of the statistic. Another formula you're going to need to know is the parameter here, or the proportion of combined samples. So we're going to end up taking our values that we're going to be giving and combining the number of successes in both of the samples and putting that over the count of individuals in both samples combined, so our samples added together. So here you would have our proportions added, and here you end up having your samples added together. Okay, usually when you're doing your hypothesis, your H sub 0 or your null hypothesis is going to end up being P1 minus P2 equals 0, or they're going to be equal to each other if you want to think of it that way. You could have also written it as P1 equals P2, meaning there's no change in what they have. Okay. All right, so the two sample z-test for the difference between two proportions. Supposing conditions are met, like we've talked about before, to test the hypothesis, you first have to find the pooled proportion, which is your p hat sub c of successes in both samples combined. Then compute the z statistic. Okay, so here, remember, you have your statistic minus your parameter over your standard deviation of your statistic, where instead, now we're going to use p hat sub c. Remember here your pictures are exactly the same like we were doing last chapter, where here if you have your alternative hypothesis as being greater than 0, it's the shaded area to the right. If it's less than 0, it's to the left. And if it's not equal to 0, then it's going to be a two-tailed distribution. You have to double your p-value. So let's get into a problem here, where we're going to talk about hearing loss. Are teenagers going deaf? In a study of 3,000 randomly selected teenagers in 1988 to 1994, 15% showed some hearing loss. In a similar study of 1,800 teenagers in 2005 to 6, 19.5% showed some hearing loss. Okay, so do these data give convincing evidence that the proportion of all teens with hearing loss has increased? So we are going to still be doing the 4-step process, but you're going to notice that they're not going to be identifying that in your textbook anymore with the icon. You're going to have to know when to do it and when not to. So here, do the data give convincing evidence? That means we're going to do the 4-step process, which is state. So first, we will test the following hypothesis at the alpha equals 0.05 significance level, where P1 is the proportion of all teenagers with hearing loss from 88 to 894, and P2 is the proportion of all teenagers with hearing loss from 2005 to 2006. Oh, there's supposed to be a 5 there. Okay. Our hypotheses, our null hypothesis is going to be P1 minus P2 is equal to 0, and our alternative is going to be P1 minus P2 is less than 0. So the plan, if the conditions are met, we should use a 2-sample z-test for P1 minus P2. So first, is it random? Yes, the data do come from 2 independent random samples. The 10% condition is 3,000 less than or equal to 1/10 of the first population, and is 1,800 less than or equal to 1/10 of the second population. So that's all that's saying is that is 30,000 less than or equal to the total number of teenagers in the U.S., and is 18,000 less than or equal to the total number of teenagers in the U.S., and both of them are. Okay, you have to do your large counts, which remember you have to do your successes times your sample size. So we end up doing 3,000 times 1,500, and then 3,000 times 1 minus 0.15, and 1,800 times 1 minus 0.995, and 1,800 times 0.9195. All of those end up being true, so we've now met the large counts condition. Okay, once your conditions, now we have to do our do. So remember that p hat sub 1 is 0.15 and p hat sub 2 is 0.195. So we want to find the combined proportion. So we have to take the successes for P1 and the successes for P2 and add them. So this 450, which we get here, and the 351 for our successes equals 801. We then have to divide that by our sample sizes added together, which is 3,000 plus 1,800, which is 4,800. So we end up getting a pooled proportion, essentially, of 0.167. Okay, we now have to fill in for our z statistic formula. We want to find out what the z value will be so we can get a p-value. So we fill in, remember we do p1 hat minus p2 hat, which is 0.15 minus 0.195 over our standard deviation of the statistics, so 0.167, which is our pooled proportion, times its failures divided by 3,000 for its sample size plus the other sample. And we end up getting a z of negative 4.05. Now remember, if you go into your table, that's not going to end up being in your table, so you end up, because it's a really low number, right, because we're having our curve, and negative 0.45 is really not even going to be seen, so our p-value is essentially at 0. After you do the do, we now have to do our conclude. Remember, we compare the p-value to alpha, just like in the previous chapter. So because the p-value of approximately 0 is less than an alpha value of 0.05, we reject the null hypothesis. We have convincing evidence that the proportion of all teens with hearing loss has increased from 1988 to 1994 and 2005 to 2006. Okay, another question or something that, just to think about would be between these two studies, if Apple introduced the iPod, and people have been out there saying that teenagers are losing hearing loss because they're always listening to headphones now with the earbuds. If the results of the test are statistically significant, can we blame iPods for the increased hearing loss in teenagers? So what do you think? Can we blame iPods? No. Unfortunately, with what we did up above, we didn't do an experiment where we randomly assigned some teens to listen to iPods and other teens not to. So we can't conclude that iPods are the cause of the hearing loss. There could be other causes for the hearing loss that we would have to also take into account. Okay, so this is just the general process for how to do the two proportion z-test. You can also, remember, do those things in your calculator, which are going to make your life a lot easier. So if you do if you do stat, you go over to tests. You want to find where 2-prob z-test is here with number 6. Okay, you have to go through and you need to enter in the values, not necessarily the proportions, but you need to change them so that they are numbers, and they need to be whole numbers, or integers, excuse me, when you put them in. So you're going to end up using x1 as being 450 because that's your success. You don't want the percentage out of 3,000, which is your sample size. Your x sub 2 is the successes of the second sample that we have, which is 351 divided by 1,800. We're doing a less than, so then we have to choose less than p sub 2. We go down to calculate, and we end up getting all of those values that we have on our screen. So here you have the z is equal to negative 4.047, which is here we had negative 4.05. Our p value is really, really small because it's times 10 to the negative 5. Okay, we have our p hat sub 1, p hat sub 2, and our other p hat combined is the 0.167. So we end up getting the exact same values here. It's just a lot easier and less mistakes will probably be made. Okay, so get used to using the calculator for this piece because you can always go and write down what you entered in the calculator on the actual exam.